Hello, guys. It's Mr. Sanchez here, coming at you with another lesson. This time it's an algebra, a calculus lesson. We will be working on determining limits, functions, algebraically using. But first, we're gonna focus on the algebraic manipulation of limits. If you hear a beeping in the background, that's just my smoke alarm. It needs new batteries, and I haven't had time to go get them for obvious reasons. We're in a hurricane. Anyways, yeah, our objective today is to explore the algebraic properties of limits. Things to know. If you have the limit as x approaches c, and then you're doing f of x plus g of x, then this thing kind of has like the distributive property where this gets distributed to both, and that's going to be equal to the same thing as the limit as x approaches f of x, as x approaches c of f of x plus x approaches c of g of x. See, that's called the addition property. We have the subtraction property, which does the same thing. Instead of addition, we end up subtracting. And we have another property called the constant multiple rule. So that means that we have the limit of some number times our function. We can move the number outside and then take the limit and multiply it by that number at the end. So it's pretty easy. When you have the limit of a fraction, then you put the limit on top and you put the limit on bottom. That's called the quotient property. When you have the limit of multiplication, right, f of x times g of x, you end up doing the limit as x approaches c of f of x times the limit as x approaches c of g of x. So you kind of separate and apply the limit to both sides. And then we have the composite function property, where let's say you have f of g of x, then you're going to put instead of just doing, you're going to put the limit inside of the first function, outer function. And you're going to take the limit of the inner function and then apply the value. All right, that's the composite function property. You should write all of this down in your notes, just because it's things you should know. You can either put them all together or have them all separate. We will be making a flashcard out of this, so if you want to get ahead, you might want to do that. Anyways, let's go to the first example. All right, it says the graph of the function f is shown to the left. So there's our function f. And then it says, what is the limit as x approaches -1 of f of x? All right, so in order to do this problem, it looks complicated, but in order to do this, you're going to have to put the limit inside our inner function. So you're going to write the f of the limit as x approaches -1 of f of x. All right, so now we got to figure out what this is. Once we figure out what this is, we can do the rest of the problem. So what is the limit as x approaches 1 of f of x? What is this equal to? Well, let's find out. If we go over here to f, we have a solid point there. So our limit there is 2, because the left side is 2 and the right side is 2. Now that we know what this is, we just got to find f of 2. And f of 2, this is 2. Where is our solid line, our solid dot? It's going to be right here. So our answer is going to be 2, which is B. I took this problem straight from AP Classroom, I believe. So if you're wondering how I got these, this is where I got them from. Or from online. I forget which one. All right, the graph of the function shown to the left, same thing. The limit as x approaches f of x from the left the limit as x approaches -1 of f of x. So you're going to do f of the limit as x approaches -1 of f of x. And oh my god, guys, I'm just realizing this said -1. But the limit as x approaches -1. Luckily, it's also 2. It's 2. All right. So, it works out. It works out just the same. But I took the wrong limit. So over here, let's go back to this one. Over here, the limit as x approaches f of x of -1. We go to -1, right? Our limit here is 3. So the limit as x approaches -1 of f of x is equal to 3. So now we're looking for f of 3. And if you go to f of 3, that's going to be 1. Okay? Follow the logic and you'll be fine. Example 2. And then I think we have a couple more examples and we're done. Example 2. Alright, so you see these are called piecewise functions. In order to find the limits of piecewise functions, we need to know what we're doing. Alright? So you see how this is saying find the limit as x approaches 2 from the right side? Think of it as a number line. Right? Think of a number line. In order to find out where to put stuff, are you going to have 0, 1, 2, 3, right? If you look at x less than 2, that would be this whole section over here. Alright, and it's on the number line. So therefore, this part is the left side. This is x equals 2, so this is exactly right here. This is at 2. And then x greater than 2, that's everything on the right side, right? So this is the right side. In order to find the value of the limit as x approaches 2 from the right, you got to know which side to plug stuff into. Alright? And now, because we're doing a right side limit, that's going to be the greater than part. So all we got to do now is plug in 4. And then since it's x plus 3, this time we're going to put 2 plus 3, which is 4 times 2 is 8, plus 3 equals 11. So that is our left-hand limit. Alright, similarly, the same thing applies here. This is the left, this is at, and this is the right. Alright, this time it tells us what is the limit as x approaches 2 of f of x. Alright, in order to do this problem, you need to know two things. We need to know that we need to make sure that the limit as x approaches 2 from the left of f of x is equal to the limit as x approaches 2 from the right of f of x. Okay, so we gotta plug in 2 to this part and to this part and hope that they're the same. Alright, so let's practice the left side one. We're gonna have 2 squared minus 4 times 2 plus 4. 2 squared is 4 minus 8 plus 4. 4 minus 8 is negative 4 plus 4. We get 0. So that's our left hand limit, right? And our right hand limit, let's try to figure that out. We're going to have 2 squared minus 4 times 2 plus 8. So this one's a little bit different. 2 squared is 4 minus 8 plus 8. 4 minus 8 is negative 4. Negative 4 plus 8 is going to be positive 4. That's our right hand limit. So because they're not equal to each other, we say that the limit as x approaches 2 of f of x does not exist. Alright. Let's go on to the last couple examples and we'll see what happens, alright? Now this gives you a table and it tells us to find the following limits. I'm only gonna do this example and hopefully you guys can figure out this second example on the bottom by yourselves. That would be like a little homework for you to keep the video short. And so it says, what is the limit as h of x, the limit as x approaches 2 of 5 f of x plus g of x. Alright, so there's a couple ways we can do this problem. And we're going to try and do this the easy way. Alright, so in order to do this, first I'm going to distribute the limit to everything. Alright, so I'm going to have the limit as x approaches 2 of h of x times 5 times the limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. Alright, so I used the distributive property and that's how I got my limit using the limit rules. Alright, so now we have here the limit as x approaches 2 of h of x. That's this part right here, right? So I'm going to replace that with 2 bracket 5 times the limit as x approaches 2 of f of x. Limit as x approaches 2 of f of x is 4. Right, so we're going to move 5 times 4 plus the limit as x approaches 2 of g of x. G of x is negative 6. Right? And this is going to turn into 2 times 20 minus 6, which is 2 times 14, which is 20. Alright, using the similar logic, try and solve for this one. Alright, and we're going to go over looking at this test prep problem so we can get some problem. And get to see what the AP exam tells you. Alright, so first look at that problem. Pause the video. Try it on your own. And now let's look at the test prep. Alright, so this is what the AP exam is going to look like. It says, if f is a continuous function where f of 3 equals 7, which of the following statements must be true? Alright, so all we know is that f is continuous and that f of 3 equals 7. So there are no breaks. So no matter what our graph looks like, we know that at 3, we're going to have 7, and there is no breaks. Alright, so if we try this one, the limit as x approaches 3 of f of x times 3 of 3x, that's technically the same thing as f of the limit as x approaches 3 of 3x. And then the limit as x approaches 3 of 3x is 9. But we don't know what f of 9 is, so we cannot use that one. You follow that logic. This is saying the limit of, this is saying f of 6 is equal to 14. And we do not know that either. This, if you apply it, you're gonna get 0 over 0. And we're not using that. We don't know that. And then this is saying f of 9 is 49. So that doesn't work either. Now, by process elimination, you could say this is it. And it is our answer, but I'll show you why it's our answer. You got to put the limit inside, right? So you see how it's squared? We're going to say that f of the limit as x approaches 3. Oh, wait, no, my bad. We'll do limit as x approaches 3 of f of x squared, right? The limit as x approaches 3, because our function is continuous and f of 3 is 7, we know that this is 7, and 7 squared is 49. That's how we get this answer. Alright? Finally, this last one, it's a left-hand and a right-hand limit. It's asking us, then, if this is the limit, what is the limit? If this is our function, what is our limit? We just gotta plug stuff in. So we need to make sure that the left is equal to the right. And let's go ahead and plug in our 3. So we're going to have ln of 9. Let's see, that's the left hand. It's the LHS. Let's see if that equals the right hand side. That's 3 ln of 3. Which is not the case. They do not equal each other, so it's non-existent. Alright guys, that's the video. Hopefully it wasn't too long. And yeah, make sure to take notes on this. And I'll see you guys in class.